Hello everyone, welcome to this video. My name is Rang Li from DJI Enterprise, and for today's video, I will be covering photogrammetry process workflow using the DJI Terra software. From today's video, you'll be learning how to import data into DJI Terra software and correctly identify the image post data, process the data, and output the data with great accuracy result. And since today's video might be a little bit long, I recommend you to click on the timeline of this video below and jump right to the section you're interested if you had experience with DJI Terra before. Otherwise, I recommend you to go through the entire video with me step by step so you can learn the workflow comprehensively. All right, let's get started. Before I open up DJI Terra software, I do want to show you guys the data which I will be using for today's process. I have prepared one data set which was captured by the Mavic 3 Enterprise drone, and this data set was flown under network RTK, and the data set over here is also mosaic data set, meaning all the photos which I captured from this drone were all native to the ground. And along with this data set, I also have 5 known points recorded, which I will be using these known points as checkpoints to verify the accuracy of the RTK drone flight. I can also use these known points as the ground control points, which I'm going to show you guys later. All right, let's get started. Open up DJI Terra software. And on the right side, as you can see, this is a map layer. You can zoom in, zoom out, and you can see that we have the DJI FlySafe GeoZone overlaid on top of the map layer. You can turn this off if it gets too clouded, and you can change this to satellite if this makes everything looks easier. On the left side, you would find 2 tabs, Reconstruction Mission tab and Flight Route Mission tab. Since we are going to reconstruct a model, we're going to make sure we're under Reconstruction tab. So over here, you can see we already have a few missions created in the past. Now these are all reconstruction missions. They might not be photogrammetry, but you can filter out by selecting visible light for photogrammetry. I am going to create a new mission by selecting the new mission button on the bottom and select the visible light because our data set was captured by RGB camera. Now we just need to give our new mission a name. And then select OK to confirm. And now we just created a new reconstruction mission. So if I go back by select back option upper left corner, I will be able to see the new mission we created. And select enter mission to go to the mission settings. I recommend to go through all the mission settings one at a time from top to the bottom. So next step we're gonna do is go to this photo section and start import your data, which in this case, photos. We can select add photos and go to the data folder and select all the photos and select open to import all the photos. Or you can select add folder and simply select the folder which contains all the photos inside and select the folder. Now this is going to import all the photos inside that folder. If you have multiple flights, for example, if your site is big, for example, you flew 3 times for this mission, and you have 3 folders generated, you can select 3 folders and import. DJI Terra is going to import all photos within that 3 folder. In this case, I just have 1 folder. And as you can see, once you import all the photos, on the left side, under the map viewer, you'll be able to actually see all the image post data or the position of the photos. Now this indicates where the drone took these photos. 359 photos represent to 359 dots listed on the map. I am going to select this 359 photos. Okay, and as you can see, this is the directory or the folder I select to import all the photos I have. I can expand this and I can highlight any photos I want to, and I can select delete and to remove any photos I don't want to include in my process. So for example, as you can see, we did a big scan over this region, and I don't want to include this specific building. I can simply select the first one and highlight all the photos right on top of this building and select delete to remove these photos. So this way, these photos will not be used for the process. Or I can, again, go to the same page. I can select this option on top and draw a section box and define a boundary over here. Once I finish that, right-click and delete photos within this section box. So this way, I don't have to include these photos for my process. But for this specific project, I would include all the photos we captured, which is 359 photos. Okay, so we just imported and filter out any photos we don't need. Next step is to define your image post data. Now this is very important. If you are using RTK drones, you do want to make sure the reference service you are using is under which coordinate system, because your drone data follows that coordinate system. So this specific case, I captured all the photos using the Mavic 3 Enterprise drone with RTK connected. It was a network RTK servers, and I know the coordinate system used from that service was in WGS 84, which in DJI Terra, we use WGS 84 as default. So if you don't define the post data in DJI Terra software is gonna think that all the data were in WGS 84 coordinate system in default. And the height is in ellipsoidal. Actually, all DJI drones, the image captured from DJI drones were recorded. Vertical datum is in ellipsoidal height. And DJI Terra, of course, by default, always think that the vertical datum is default to ellipsoidal height. So it's gonna read everything in ellipsoidal height, unit meter. All right, so over here, you have three options. So you can select to export post data. By selecting this option over here, as you can see, it pops up a window for me to export post data of all these 359 photos. And it's gonna in a format of TXT. We can then import post data. So for example, if you're using PPK method, post-process kinematic method, and you correct all the post data of all the images, and then you need to define the post data and overwrite to the existing old post data of all the images, you need to import post data by selecting this option and select the OK. And then you select the new post data file and select open and overwrite the existing pose data. If you are just flying the drone under GPS and you don't care about global accuracy of your result, you don't have to change this. The third option is to view the existing pose data. As you can see now, it showed me the photo name, longitude, latitude, altitude, pitch out roll, as well as horizontal, vertical accuracy. Now, select Edit. You're gonna see a new window popped up, Format and Properties. So this is essentially the data we just saw, but this page allows you to change and identify data column by importing a new set of pose data. So this is very handy when it comes you using a DJI drone with RTK enabled and connected to a N-trip service. However, your N-trip service was in a non-WGS84 system. That way, you can simply select over here, Pose Data Coordinate System, and select Known Coordinate System, and then change this, which is, again, by default, WGS84, to any other geodetic coordinate system you need. You can select the Horizontal Coordinate System and search from here. For example, I live in North America, and over here, most systems were used under NAD83. So if I connected to a network RTK service, it was not in WGS84, but in NAD83, and I can select NAD83 and define all my data were collected under NAD83 coordinate system instead of WGS84. Now this is very, very important because if you don't change this to NAD83, DJI Terra is going to think that all the data you recorded were in WGS84 and your output is going to be off. But for this specific data set, I know that the N-trip service I was using was under WGS84 coordinate system, so I can leave everything as it is. So I'm actually going to select cancel, and I am good to go. All right, so that is the image pose data setting. Next step is camera information parameters. Right now, you see this little check highlighted in green, which indicates my camera parameters are all identified. The reason is this data set was captured by the DJI drone. So the DJI Terra software is able to pull up the camera parameters from the images directly. So the software knows, oh, these photos were taken under Mavic 3 Enterprise drones. So I don't have to change anything. However, if you are importing photos, which was captured by a third party, which meaning non-DJI drone or cameras, you will need to define the camera parameters. So go to this little eye icon, and you will need to import a new profile and identify the camera parameters over here and apply the new profile to the images you imported for accurate output. Okay? But again, for DJI drones, you don't have to change anything. Okay, so that is photo section. This completes the data import. The next step is the actual processing. So we have aerial triangulation. Let's expand aerial triangulation and deep dive into aerial triangulation process step. So under aerial triangulation, we have scene settings, we have computation method setting, and we have advanced settings. I am going to collapse advanced setting for now. The scene settings, we have three options: normal, circle, and power lines. Unless you're outputting a 3D model, you would select normal. If you're outputting a model which you wish to reconstruct and you were flying not in a great mission like this, but instead you were orbiting the object for vertical structure, you will select circle. Similarly, if you're reconstructing a model for power lines, you would select the power lines. In this case specifically, it was osmotic dataset, so we would select normal. Computation method. So we have standalone computation and we have cluster computation. Cluster computation is only available for cluster version of DJI Terra. The cluster version of DJI Terra utilizes multiple machines with multiple GPUs to speed up the process by utilizing GPU power from multiple computers. In this case, we just select standalone. Advanced setting, let's expand that and deep dive into it. So we would find our ground control point management settings over here. Now this is the same setting page you would import the checkpoints as well. We're going to deep dive into this section specifically later, but for now, let's keep going. Feature point density. Now this is the density of your aerial triangulation model, because the output for the aerial triangulation model is in a format of point cloud. So it's asking you for outputting the density of that point cloud. So you can select high or low. I usually recommend high because when you select low, it doesn't go much faster compared to high. Usually Aerotriangulation process is a fairly quick process. Then you have distance to ground subjects. Now you can leave this as a default if you're outputting osmotic map. If you're doing 3D scanning or 3D reconstruction, and if you're outputting a mesh model or point cloud model, you will need to define the highest subject within the scene, and you need to know the distance between the top point of that subject to the ground. But if you're only doing 2D reconstruction and if you're only outputting out a map, you don't have to change anything. You can leave as default. Then we have output format. You can turn this off. You only need to turn this on if you wish to export out the model which was constructed from the aerial triangulation phase. Usually I will leave this off because I don't really need to use that aerial triangulation model. But you can enable this and select the coordinate system as output. Okay, next step, we're going to get into the ground control point management page. Select GCP management. And as you can see, the map viewer disappeared, but instead you're gonna get a 3D space viewer, which show you by default the image pose in 3D. So this is very neat because you'll be able to see if you're missing any photos directly, and you also be able to see if all the heights of all the photos are consistent. As you can see, they're on the same layer. That means the flight height is consistent for this specific flight. But if you have a terrain photo flight, for example, you'll be able to tell from this page. And if I zoom in real quick, it actually tells you where the drone flies. So this little triangle indicates where the drone heading was. So it was flying, the drone was flying this way, making its turn and going back. That's the 3D space viewer. You can actually disable or hide this if you want to. Over in this page, you will need to import your ground control points. But before we do that, again, from top to the bottom, go to the GCP coordinate setting or system setting, expand this and define your coordinate system again for your known point. The data I have prepared for this specific video, I can open it up here. I have 5 points over here. I recorded these points in WGS84 geodetic system, and the height is ellipsoidal height. So in DJI Terra, I would select WGS84 geodetic and default, which is ellipsoidal. Once I finish the setting, I can start import these known points. Under the GCPs, you would find import mark file and import GCP file. Import mark files and import GCP files functions the same, however, different format. If you select mark, import mark, it's going to ask you for a JSON format file. However, if you select to import GCP file, it's asking you to import either a TXT or CSV format file. And the third option is to export out the GCP. So once you import the GCPs, you can export this GCP for a different project. So next time you can simply import these points again, and it's very easy. You can select Add GCPs. So once you select Add GCPs, you can start import latitude, longitude, altitude, or XYZ manually. You can select Delete GCPs. So since I have all 5 points saved in this CSV format file, I am going to select Import GCP file and go to that directory, select that CSV file, and select Open. Okay, as you can see, that format and properties window popped up. We need to define the data column. Which data column means what? So the first one is the name. So I'm going to select it and define it as a name. Second one is the sequence or the index. I am not going to use it, so I can leave it as undefined for now. Third one is latitude. So I'm going to select latitude. Next one, longitude, and then elevation, which is my altitude. And antenna height, I don't have to import that. Horizontal accuracy, vertical accuracy, I'm going to leave as default. And then I am going to select known coordinate system and make sure it's under WGS84 geodetic and default, which is ellipsoidal. However, something I noticed is define data column is now giving me a number of 6, which I only have 5 points, because DJI Terra would think the first row is another data, which is incorrect. I'm going to ask it to start counting from the second row. So over here, lines to skip from top, I'm going to change that from 0 to 1. And then I should have 5, and which is correctly identified. Once everything looks good, let's select the import. Okay. And wait for a while, and you should be able to see your known points show up in the space viewer. And for this specific project, I am actually going to use all points, not as ground control points, but as checkpoints. So I am not using any of these known points to tie the accuracy, but instead I'm using these points to check the accuracy. Okay. The next is actually to go to every single point and start tying these points to the model. But before I do that, I highly recommend to select Aerotriangulation to get the Aerotriangulation first before you start checking these points. Because if you're having a terrain difference, we're in an urban region right now, so everything is pretty flat. However, if you're in a non-urban region and you have terrain happening a lot, it's going to give you a hard time finding these targets without the Aerotriangulation model. So I recommend to select that Aerotriangulation before you tidying any GCPs or checkpoints. Okay, we're just going to wait for this to complete, and this shouldn't take long. Okay, so the process is now finished and we can start marking these points now. You see this tip shows me the reconstruction is complete. I'm just gonna select OK. And if I rotate this real quick, as you can see, it shows me the surface. And this is way easier for me to start marking these points and locate these points. So I'm going to start from the first point. I'm gonna select the first point. As you can see, these yellow lines, which indicates distance from the point to the photo. On the bottom, the photo gallery options, I can select this option to only display photos with ground control points. That means if I enable this, there's only 56 photos among that 350 something photos which contain these points in the field of view. I'm going to select the first one and I'm going to start marking these points. And simply, you're gonna see this little blue circle over here. As you can see, it's a little bit off. It's actually in the middle of this cross over here. So I'm gonna mark, and by dropping off the green cross over here, as you can see now, this photo is indicated as marked. On the right side of this checkpoint, it shows marked number 1. So that means one photo has been marked. And you also notice this checkpoint icon is now in green instead of gray. I recommend to mark at least 5 photos per checkpoint. All right. So just like this, you would need to make sure you marked at least 5. On the right side, as you can see, now you have a projection error, which is the arrow indicating the accuracy of the result. The 3D point arrow is in format of pixel, also in a format of meters. Once you finish marking all these points, the next step for you to do is to select Optimize. Once you finish that, you would have a report to indicate the accuracy of this data set. And since I use all the points as checkpoints, none of these points as ground control points, it's going to use all these 5 points again just for checking the accuracy. However, if you do want to use known points as ground control point, you simply just need to make sure to select the point you want to make the ground control point. For example, I want to make the number 3, this point specifically, as my ground control point. I can select type from checkpoint to ground control point. And once I've selected that, the icon changed a little bit, and I can select Optimize to apply the location of this point to my model. All right, so I would start marking all these points, and I would process out and by select Optimize. And since I have this data set processed before, I actually have the result over here. So if I go to same GCP management, as you can see, I have seen 5 points marked, 5 each. And I can select Aerotriangulation report. And this is going to pop up a HTML web page. And it shows me all the parameters, for example, the point cloud density, whether we want to generate XML format of this model, which computation method we select, just like what we went through. And we also have 359 photos. Show me the process time, which is 3 minutes. And it shows me all the checkpoints used and the accuracy result. The accuracy result is in meter. And this specific flight was 1 centimeter ground sampling distance. As you can see, the accuracy of this specific model, XY, is within 1.3 centimeters, and Z is within 1.4 centimeters. So it's very good. Over here, it also shows me the RTK status. So if it's under fixed, that means the drone was under RTK fixed position normally when the drone took the photo. So 359 photos under fixed, that indicates we had a good RTK connection during the flight. It also shows me the camera calibration information, which is the parameters written into the image. So once we checked and verified our accuracy is good by using the checkpoints, we can then proceed to process out our deliverable. I am going to go back to the project we just created. And I am going to collapse everything. So we just finished the aerial triangulation. We import the checkpoints and ground control points. And then we select the optimize to optimize the model with import of GCP and reconstrain the model using the GCPs. Well, in this specific case, we didn't. But if you want to import GCPs, you can again define the known point as GCPs, and then select optimize to constrain the position. The next step is for you to select output. So we have two options. One is 2D map, the other one is 3D model. If you just want to export out a 2D map, just enable 2D map option. And if you want to output both, you can select both. Before I dig into the settings for each, you need to make sure what deliverable you're trying to output. So again, this specific data set, I want to have the 2D osmotic map out of the entire scene. So I planned out my mission based on the need of 2D map. However, if you're planning to reconstruct this model in a 3D format, I may need to reconsider how I was going to fly this scene. I might select oblique mission type to capture this scene with different angles. But for today's video, I am going to select 3D model anyway, just to show you the result afterwards, because once you select 3D model, you will have some settings you will need to change, which I would like to show you guys. But just letting you know that if you select 3D model, making sure that you have enough photos with different angles to cover the scene that you're planning to reconstruct. As you can see, I'm not even getting any points on the side of the building because all the photos are native to the ground. As you can see, not many points were generated from the facade of the building. So not expecting the result looks good from the 3D side. But for now, we're going to select the 2D and collapse 3D model option to go through the 2D map settings. First of all, we have a resolution. So we have high, medium, and low. High means the 100% resolution. Medium is 50% of resolution, and low is 33% of the original resolution. Usually we will select high. And under scene, we have urban, field, and fruit tree. So I would always recommend to select urban, unless you have an Argus series drone and planning to use this model for mission planning or Argus spraying drones. Otherwise, always recommends to use urban. Fruit tree similarly. If you're not using Argus series drones for agriculture applications, I don't recommend to use any of these options. So let's select urban. Computation methods, we just covered basically. If you have a cluster version, select the cluster version to speed up the process with multiple GPUs and computers. Let's go to advanced. So under advanced, we have region of interest. If we select the region of interest option, and you would find the DJI Terra software is actually asking you to define a region for reconstruction. So let's say, similarly, if I just want to, I'm going to hide the camera pose. It looks a little messy. If I select this option, editing mode, and I can actually start defining a region. or I can draw a boundary. As you can see, everything highlighted in the yellow region right now is my region of interest. So DJI Terra is actually going to generate a map only within this region. So this is pretty handy if, for example, you just want to have the software process out a certain region and not an entire region, just to save the processing time and speed up the process in general. You can do that by doing this. You can also import a KML as the boundary of the region. Otherwise, you would select the maxed region mode to output everything. Okay. All right, so that's the region of interest. I'm going to exit this out and not changing anything by select go back. Next step is output coordinate system settings. You need to select a specific coordinate system to output the data. So over here we have arbitrary coordinate system setting, and we have known coordinate system settings. Arbitrary coordinate system setting is pretty straightforward. It's just going to export you out the model or the map in XY Cartesian coordinate system. You can also actually use this little icon highlighted here, which is our 7 parameters transformation settings, to transform your existing coordinate or to your target coordinates by import that 7 parameters. So I'm going to select this option real quick. As you can see, the 7 parameters transformation settings popped up, and we have 2 settings. The first one is to calculate 7 parameters, and the second option is for you to define the parameters to transform your coordinate from arbitrary to the target custom coordinate system. So to calculate 7 parameters, you will need to import 3 sets of coordinate points. You can choose to import in a format of TXT or CSV, or you can manually add these points and import these points. But basically what you need for this specific process is you will need to have the source coordinate point, which was in WGS 84 in this specific case, and you will need to have Cartesian coordinate point in XYZ, and you have to have at least 3 sets of these points to calculate out the 7 parameters, and then you can export out these 7 parameters to save. And next time when you have a new project under the same region and you want to apply that same coordinate shift, you can apply that same old 7 parameters transformation, which contains all the 7 parameters, and apply to shift from your WGS 84 or NAD, however your source coordinate is, to your custom target coordinate in projection. So again, this is only needed, I'm going to select cancel. This is only needed when you are working on a project that requires custom coordinate system, okay? You can also select a known coordinate system. You can select import PRJ to import a PRJ file to define the system, or you can select in the Terra database. So horizontal datum settings, right now as you can see, it's default to a projected WGS 84 based on your project location. So if I select this and if I scroll down under horizontal coordinate system database, select this, you will find geodetic coordinate system and the projected coordinate system here. Now this includes a lot of coordinate system needed for you to define your output. I highly recommend to use the EPSG number to define the correct coordinate system for the output. This is very important. If you don't output your data in the correct coordinate system, your client might find the data is off. Select cancel for now, and I am going to select the WGS 84 UTM zone 11 north for now. And the vertical geoid setting, I am going to cover this a little bit. Under the vertical coordinate system database, select this option, and you will find the vertical datums here available. Based on where you're at, or United States, we have NAVD 88. And as you can see, we have different formats here available. And over here, we have different geoids available for you to choose from. This is very important. You also need to define the vertical coordinate system correctly. Otherwise, your data is not going to be accurate at all. So over here, I am going to select 2018 NAVD 80A in the format of US foot. So I'm going to select OK. This is just one example. Again, based on where you're at, based on what exact coordinate system format your client is asking, this varies a lot. Next option is the map grid. The map grid is basically an option for you to crop out this map into multiple smaller ones. So why would you want to do that? For example, some software might having a hard time importing a large map. This is okay, this size is okay. However, imagine you have a large map and software might have a hard time. So crop them out to a smaller sections and import them separately will be easier. So you can define the maximum pixel size of your map section. So DJI Terra is going to automatically crop out. So in this case, we're not going to use this. And the second option is light uniformity. Light uniformity as well as the haze reduction is only needed when you're experiencing issue with light being ununiform. This could happen, for example, if you're using a camera that was capturing data set in different time, and the shadow could cause the light being not uniform across the entire map. You can enable this to help reduce that effect, but not recommend you to enable this unless you're having this issue. Similarly, this would remove the potential haze might be caught in photos. Okay. In this case, I'm not going to enable these two options. And once I finish the settings for the 2D map, I can select Start Reconstruction to output the 2D map. I am going to select Start Reconstruction. As you can see now, a parameter checklist popped up. Now it's telling me to check all the parameters and make sure everything looks good. I can see right now I have an issue which one of the known points has been identified as a checkpoint, which is not right. So for example, like that, I can go back to Aerotriangulation, and because I did this for demo earlier, I'm going to select this back to checkpoints. Just so if you checked any parameter which is not correct, you can go back and change everything before you start the actual process. Now everything looks good. I can select OK, and DJI Terra is going to start the process. Again, I have this data set processed already. Over here, I actually have the data, which is this one. So once it's finished the process, we can see the map has been overlapped on top of this satellite map layer. I can switch to regular, so that makes everything looks better. If we scroll all the way down and select the quality report, now this is going to show me the Aerotriangulation report, but also since we have finished the 2D reconstruction, now another section is going to pop up showing the quality report for 2D reconstruction. It's going to give you the parameters that you set for this specific project, the True Digital Ozone Mosaic preview, and it's going to show you the general information, including the covered area, ground sampling distance, as well as the flight altitude in average, showing you the time DJI Terra used to generate the model, and it shows you the digital surface model preview as well. Yes, so DJI Terra actually outputs the digital surface model along with the digital ozone mosaic map. It's going to show you the preview of that. model, and it shows you the scene overlapping. So this is pretty handy. So if you are not seeing this scene overlapping over purple, that probably means that you have some region not having enough overlaps. So your photo may not have enough overlaps to reconstruct the model needed. Sometimes you could generate a little hole inside of this map because it doesn't have enough overlaps. But that is the 2D reconstruction process. So at this point, you're finished with the 2D reconstruction. Let's go back to Terra. Okay, so let's go back to the main menu. And over here, select the open folder. And here you'll be able to navigate to a folder named Map. Select Map, and you'll find your result.tif file. Now this is the final GeoTIFF format output of your map. So this is your final result. And you also would find another file is named dsm.tif. Now this is the digital surface model. As you can see, the result file.tif and dsm.tif, they also have their corresponding true world file TFW format. So these are the deliverable you can find. All right, so once you finish everything, that's the 2D map. You can collapse this, and this is ready to go. Let's go to the 3D model settings for now. And for the 3D model settings, you will find settings are pretty familiar to the 2D mapping settings. First of all, the resolution, high, medium, low. And you would find the scene. This is grayed out because for the aerotriangulation, we set normal for the scene instead of circle or power line. But you would find a computation methodology being standalone computation or cluster computation. Again, just like what we covered, if you have a cluster version of Terra, you can use this. Otherwise, not using this. Advanced settings, similarly, we have region of interest for 3D as well. Select region of interest over here. And this is basically where you would define that region. If you define the region before in the 2D reconstruction, you can copy that to 3D and it's going to show you here automatically. But one thing is different about the 3D block settings is DJI Terra can actually split out the entire model into smaller blocks. So based on the memory size you defined, for example, I can define to 10 gigabytes per block, and I can apply this. And as you can see, DJI Terra can estimate how many blocks it will generate. Or for example, for this one, it's going to give me roughly about 4 blocks. I can also split different blocks based on the length. I can select the custom side length and define the block based on the length. In this case, I am going to select auto. Okay. Next step we're going to do is we're going to go back to the settings real quick, and coordinate system settings, as we covered, same thing, same option. You can actually custom model origin if you want to. So if you enable this, you will need to define the origin point for this model, and specifically in longitude, latitude, altitude. This changes based on which coordinate system you select, and you can define that in DJI Terra. Output format, so you do have a format options for you to choose from. For the 3D models, you can select whether you want to output in a format of point cloud, which it would output LAS, PLY, PCD, S3, and B, which I am going to select LAS, which people probably use LAS more. But for the mesh model, we have B3DM, which is by default. But you can also output OBJ if you need it, or PLY. If you select multiple output options, it's going to generate multiple folders with the same result but in different format. Refined water surface is only needed when you're having a 3D model which contains water surface. When processing photogrammetry models, whether it's a map or a 3D model, the water surface could always cause issue, and DJI Terra has a specific algorithm just to optimize that. You can enable that if you need to. But that is all the settings for the 3D modeling. So we can start to select start reconstruction, and it's gonna pop up a checklist. Make sure your parameters looks right and everything looks good before you select OK. Once you select OK, the software is gonna start the actual processing. We have processed this data before, and I can show you the results by select this mission. Again, I am going to change this to satellite, and I am going to hide the image pose so looking better. So we have the aerial triangulation model, which we processed. I can also switch to 3D model. I can inspect and rotate my model directly from DJI Terra. As you can see, the result looks pretty good. I can identify objects on top of the building, and yeah, looks good already. So other than inspecting the actual model, the next step we're gonna do is to do some quick measurements. So DJI does pack with some measurement tools available. So upper right corner, you will find a annotation and a measurement tool right next to the show or hide camera post option. If you enable this, you will find 4 measurement tools. The basically coordinates, measure any coordinate on the map or the model. You will also find the linear or length measurement. You can also do area measurement directly from DJI Terra. Okay, and you can also measure volume if you want to. Basically, similar concept, you just define a region. And right click once you finish, it's gonna show you the volume. Over here, this is the annotation measurement, but you also find another annotation measurement option. So the only difference between these two is the one on the bottom actually can save measurement results. For example, they all have the same 4 measurement types, but this one is only for quick measurement, and the annotation measurement under the application section, it's for data storing. You can actually output the result. So for example, if I select this and if I do a quick area measurement, and I can save this result, and I can highlight this result, manage, and export. And I can export this as measurement if I want to. Let's go back. That's everything about the DJI Terra software in terms of processing and measurement. So at this point, you have finished the processing. Now you have the results ready for you to proceed moving forward to any third-party software for all kinds of use. So let's go to find the actual deliverable files. So if we select the folder options over here, this is our project, but you will find an open folder option bottom left corner. Select that option, and you're gonna see a folder popped up, and this is the folder of your mission. Under models, if we open up models, open up the PC folder, 0 folder, and you will find Terra _B3DM file. Now this is the actual model in the format of B3DMS. So if you output your model in the format of LAS, you'll find another folder, Terra _LAS. Similarly, if you select other settings for the output, such as PLY, you'll find a different folder, Terra _PLY. And within this folder, you will find the model reconstruct. All right, with that being said, that's everything about DJI Terra photogrammetry process. If you have any questions, please feel free to reach out to your closest dealer, or feel free to contact support@dji.com. Thank you.